Hey everybody, thanks for joining us. My name is Isaiah Weiner. I'm a manager of solutions architecture in the partner team. What that means is that I spend most of my day working with ISVs and consulting partners, not necessarily directly with customers. We do get a lot of customer escalations.
Hi, I'm Henry Axelrod. I'm the tech lead for the storage partner segment. So I'm a partner solution architect, which means I, work with various storage partners on their integrations with AWS. I've also been out in the industry as a customer for better part of 20 years.
So today we're here to talk about migrating workloads with funny I/O patterns, and how do you sort of plot a course so that you don't get in a position where you have to back things out. Just to help us guide the conversation, if we could have a show of hands, who's a partner? Cool. So most people are customers. That's great. If you're a partner, are you a consulting partner or are you a technology partner? ISV or like an SI? ISV? Okay. All right, cool. Great. All right, I think we're ready to get started. So
let's get going.
Yeah, awesome. So is it okay with you guys if we sit? Yeah. All right. Thanks.
Yeah. And just before we jump in, we just also wanted to share a few, other breakouts that you guys might be interested in. So feel free to grab a screen capture, or take a look at some of these other sessions that are part of the Global Partner Summit.
So the format for today is going to be we're going to talk sort of in a dialogue. We have noticed, at least I've noticed over the last few years at reInvent, that when I stand up and read text, that it does not necessarily the most engaging format. And so we thought it would be better if it was a dialogue. We've both been customers in the past, and we have found that the kinds of questions that customers ask, or the kinds of discussions that we end up with customers, lead us to guide our partners towards making better products. And so we hope that one day nobody will have to ask the questions that have led us to build this content. We will have a live demo, and then we'll have some discussion afterwards as well. And we'll stick around afterwards if you guys want to ask questions. So the challenge is that there's this notion of sort of peak to averages. Like, for example, the reason that everybody loves S3 is that you can't be your own noisy neighbor. But in on-premises infrastructure, that's not necessarily the case. And when people look at moving things to the cloud, that's not necessarily the case either if it's something that they're going to manage inside of their own VPC. And so the three questions that pop up in a recurring fashion are, how should I scope my migration? How do I move the bits in a way that is going to be effective? And then how do I pick my solution? Now, the last one is something that Henry and I are well-versed in. Because we work with all of these ISVs, people often ask, I see in the marketplace there's thousands of offerings. How do I know which one is the best one for me? And so we're going to start asking questions that hopefully will steer you towards that answer. There's also inside of the APN, which is the Amazon or the AWS Partner Network, we have a programmatic approach called the Competency Program, where we shortlist solutions that we think customers are going to have a good day with. And then ultimately, when we work with the field, the engagement process that a customer has, not only with their SA, but also with the field support of that partner, it all goes back to whether or not we would recommend something. So very often somebody will say, hey, would you recommend Acme NAS inside of my VPC? And the answer might be yes, with maybe some caveats, because I want to find out what kind of workload you have. Or the answer might be no, under absolutely no circumstances would I recommend that. And so those are sometimes difficult conversations to have. The good news is that we get to sort of stay somewhat neutral, because we're in this for customers having a good day. We're not in it to make money for our partners necessarily. Not to say that we don't want them to be successful, we do, but we start with our customers and we work backwards, and we want them to develop superior products.
Absolutely, and that's where we really kind of focus. So when we're talking about solutions, we're talking about from a customer perspective and what customers are able to gain through those various solutions. So we're not promoting products, and we don't put products in our competency because of, anything the partner is doing other than, helping customers and being beneficial to customers. So when we're looking at what solution to pick, it's going to be purely data-driven based on the requirements that we're going to talk about in a few minutes, so both from a performance and a feature perspective.
So when people start down this path, a lot of times they have a checklist of things that they want to work on. And Amazon, we say that without a mechanism, everything's just good intentions. So we want to help you build a mechanism to that end, something that you can, if you don't have an approach to this, it would be the sort of thing that if you don't have a checklist, these are the things that you would sort of want to stage and scope the work in. So we start with identify. And identify is important because it's the initial part where you're going to do data gathering. It's the approach that you're going to take when you're investigating into things that you actually might not have any insight into. And what I mean by that is that if you're an application owner, you might not know anything about your infrastructure. And if you're a person who works in IT, you actually might not know anything about your applications. And we see this a lot. So we want to meet in the middle somehow. The second step is to baseline your performance. That doesn't mean run a benchmark. Benchmarks are a religious topic inside of Amazon. And when I say they're a religious topic, I mean we have lots of people who say things like, without this industry standard benchmark, how can a customer know what to expect? But the flip side to that argument is, without trying your workload, how can you know what to expect? So you could run the benchmark, and if your application workload doesn't look anything like your benchmark, then it doesn't help you, right? So the right answer in some cases is to do both. For example, in financial services, the stack benchmark is something that people sort of use across the industry to know whether or not it's something that they should even look at. Whether or not it works for their workload is orthogonal to that. If they don't have the benchmark, it's a checkbox requirement, they won't look at it. So we don't necessarily mean benchmarking, but we do mean baselining to understand whether or not you're going to have that peak to averages problem, whether or not you understand what your individual workload is. The third part is giving things a go inside of AWS, and part of that is deciding where to put things. And where to put things is made even more difficult after today's announcements. There's new storage services and there's new features that approach things from new angles. So for example, if you have an HPC environment, you might have a Scratch environment on a service that we released today, right? The FSx for Lustre. And that might be not what you need because you might need something that's persistent all the time. Maybe a Scratch environment isn't what your workload needs. And so that's the kind of thing that you need to look into as well. How am I going to be using it? How are my users going to be using it? Do I need the notion of multi-tenants? And then lastly, after you do move it to AWS, how do you make sure that things are healthy? Because as we all know, nothing is stagnant forever. And not only does if you're in IT, not only do your applications change their profile over time based on the success or failure of your business, but if you're in the application side of things, you're probably making modifications to your applications. You're probably changing the I/O profiles. And so that means that a combination of how your application behaves when combined with the load at scale that you're giving it, combined with how things on our side work. For example, if you're using one of our multi-tenant services, you might find that it doesn't behave all the time the way you would expect. And these are all things that we can help with from a monitoring perspective. So what are some candidate workloads? Well, the easiest ones are things that are touched by people. And what I mean by that is that we've gotten a lot of data back from technology partners that show that things that are managed by people, generally speaking, after like 30 days, 98% of the data isn't touched anymore. So this is a nice low-hanging fruit. Test and dev environments are things that are often fungible. So these are great candidates. File synchronization processes are great candidates because, generally speaking, they're repeatable and you know very well when things aren't going the way that they're supposed to go. Things get more complicated when you get into things requiring like MPI compatibility and fully POSIX compliant platforms in the form of HPC clusters. And then lastly, because everybody tends to sort of pile everything that maybe should live in a file system into a database these days, it's often the case that databases have weird I/O patterns. think I left anything out?
No, I think you covered it pretty well. It's just, I think also important to know that, what resource constraints happen on the different, candidate workloads can affect what your overall I/O requirements are going to be. So, for example, like you said, in file synchronization, you might have a much more throughput-heavy requirement. It could still drive heavy I/O depending on how much you're actually pushing through, but you have to consider the throughput implications on top of just looking on the I/O. So if you're looking at it from purely simplistic perspective of okay, let me just do an I/O profile, but not considering things like throughput, depending on which of these workloads or what your ultimate workload is, you may be able to meet that I/O requirement, but your end customer who's utilizing that is not going to be happy because it's not going to meet their throughput requirements that they have.
So it's funny you should mention that actually because you guys know DMS, our database migration service. People sort of stand it up and leave it up. And one of the most common use cases is that they'll have an OLTP environment on-prem and they've got data in their OLTP environment that they're collecting that they need to run OLAP jobs on. So they'll use DMS to actually synchronize the data out of their OLTP environment into their OLAP environment. The OLAP environment might actually be inside of AWS where they can spin things up and spin things down. And they don't care how long things take, as opposed to their OLTP environment where they do care how long things take, right? These are sort of this notion of I'm going to be a noisy neighbor for myself in the process of synchronizing something that's actually, I think it's pretty real. It's a real phenomenon.
Sure.
You were in the media industry before. What were the things that when you were doing I/O profiling that were the most important? Did you have seasonal elements? Was it time-based constraints?
I think it was a little bit of all that. I mean, we definitely had, peaks depending on, what was going on at a particular time, not only based on the application that you could see historically over time, but, there was event-driven, I/O load or event-driven throughput load in the media industry especially, and that's why I mentioned, throughput is very important, when you're dealing with, sequential I/O and reading big video files or other types of media. There would be, let's say, tentpole events that you may or may not know about. There may be, just immediate events like a celebrity dying, for instance, that would have, us restoring a lot of data from archives onto primary storage and processing that data. So understanding, not only what your application pattern is regularly, but what the capabilities of that application are. So,
what
for
were
instance,
your corner cases going to be?
Yeah. So if you had, a need to actually fully exercise your farm, if you had a big compute farm and you needed to fully exercise that at peak, what that ultimately looks like, and do you need to account for that?
So when people are looking at their I/O patterns and they start collecting data, that data that they're collecting, what I hear you saying is don't collect it for a week and think that you've seen everything.
Yeah, absolutely. I mean, when you look at file profiles profile of performance in a very narrow way, you can profile something for an hour, for a week, for a day, for a week, for a month, right? And depending on how long you profile it for, you may or may not get the full picture of what's really going on in your application. There's certain applications that run jobs that only run once a month. So if you are only profiling, over a 24-hour period, which sometimes people do, right? They're like, hey, let me just look at this application over 24 hours and, I might get an understanding of what my profile is for that application. But what if that application runs its major job that produces the majority of its I/O on a monthly basis? That happens a lot in financial applications, for example. They do monthly reporting, right?
So my two-week data set, if it doesn't include the end of the month, is not going to be sufficient.
Absolutely.
So what do you think a good period of time is for people to actually start looking at the data for?
I think a minimum of 30 days is really, is really critical if you want to capture the majority of what workloads really are doing.
So that's for the high-level stuff, not necessarily for digging into it, but for looking at the aggregate.
Absolutely.
Another thing that often comes up is that the granularity of the reporting data isn't as granular as what your application might see. So your application might see problems from a second-to-second basis, and then when you go look at, let's say, your filer, you might see minute or 5-minute time frame data, and so you've missed that entirely, and the vendor doesn't believe you, and whatever the problem has, it's on your end, right? So these are sort of classic conversations. So when somebody's looking at actually, let's say they've identified all of their stuff and they're looking at, okay, how do I move this stuff to AWS. What are the places that sort of jump out for you as the right places to put things? Is there any low-hanging fruit? Are there things that you think are worth mentioning? I know personally that I think certainly ISVs, they tend to look at things like S3 as being the Swiss Army knife of storage because of how the semantics of things work. And so if you're looking for 150 microsecond latency on an I/O, S3 is not the right place for that. But if you have a partner solution or something like that that can live in the middle and abstract that for you, then you can take care of sort of two birds with one stone type things. Do you think it's cost driven? Do you think people are looking at sort of the thing that they've heard about? How do people approach where to put stuff?
Well, I think it's a little bit of a mix because, I mean, one aspect of it is cost and performance like we're talking about today, but also, the actual features that are required.
For sure.
And AWS has, a lot of different services in terms of storage. And this is, kind of a 300 level class, so I'm not going to go into the very basics of each of the services, but, and this is already really outdated based on if anyone's at Andy's, keynote this morning, they'll know that we released, several new services and new features and have, a much more extensive slide. So I would definitely recommend if you haven't seen it, it'll be on YouTube soon or available for streaming. So you can get even more update, which includes the new FSX for Windows and FSX for Lustre services, as well as some new S3 tiers.
SFTP transfer as well?
SFTP transfer, absolutely. But just on a high level, we offer for services for object, block, and file. And as I mentioned, file is now extended because previously we just had EFS, which supported NFS. Now we have services for FSX, which is a service for Windows. It offers real full SMB support. As well as Lustre for HPC workloads. But at its core, aside from directly using these services, they're building blocks for a lot of partner solutions as well. So depending on what your application really needs, for example, if you have an application that doesn't speak S3, a lot of applications these days are starting more and more to support object and support S3. But not everyone does. Not everyone's going to get there. And depending on how you're actually doing your migration, whether you're looking for purely a lift and shift where you're taking the existing applications and just migrating them as is, or if those applications, if there's time, money, and other constraints to refactor those applications to be what we call more cloud native and support the native baseline services like S3 and others, you may be constrained by purely the features that you require. Now, if you want to, for instance, get the durability and the scalability and other factors that S3 brings to the table, but you require a file protocol like, let's say, SMB or NFS, there are solutions that can bridge that gap. So it's important to understand what those features are. And actually, if you're talking about an on-premises environment where you have a SAN or a NAS, it's often very multi-tenant in nature. So depending on what you're actually going to be migrating, you could be migrating one or more of those applications, and each of them may have different dependencies.
So the server's only one component, right? There's also a client component. Let's go to the next slide. One of the things that we noticed is that every workload that people are trying to identify is going to have sort of things that you could call out as maybe a primary strength. So for certain types of vertical use cases, there's vertical workloads that happen to load a bunch of stuff into memory, and then once they load everything into memory off of disk, no matter how fast the disk is, it doesn't really matter, right? Because they have to load into memory first, and then they operate on it. We have stuff that's massively compute heavy. They're vertical workloads. We have things that are extremely network I/O driven. Maybe it's cluster nodes talking to each other. And then from a solution perspective, you have the question of can I meet my IOPS and can I meet my throughput requirements? And you don't actually know what those are until you start measuring those sorts of things. But because we have so many different types of instances, one of the big questions is always, okay, I've identified my workload. Now, I know which product I want, right? That's what it boils down to. I know what product I want. It checks all my boxes. It's got instantaneous snapshots and writable clones, and it tiers to S3, and I can shut it down, or I can scale it up, and I can scale it down as well. That part's important. So now what do I launch it on? And so the hardest part there is figuring out whether or not what you launch it on in day one is what's going to always be the case, right? So for example, in something that scales out, you can often start changing the instance types that you're deploying, and then you can roll through the cluster and update the rest of the instance types that are older. In something that might be active passive, you have to take a hit every time you're going to upgrade an instance type. Actually, Henry's working on Alexa for business integration, so you can say stuff like, Alexa, upgrade my filer, and it makes a bigger instance. So one day you'll probably be able to do all of that by voice recognition, but the fact is today that it's often hit and miss. So part of the identification is not just what is going on at the storage layer, but also what's going on my clients. How have I sized my clients so that you can right-size the instances when you get into AWS.
And I think one of the reasons why that's important to understand is because on premises you may have, especially if you're talking about block level storage devices, you may have fiber channel that you're running things through, and that concept doesn't really exist as you go to the cloud and to AWS. So you need to account for the network traffic that's going to be produced by your clients as they're accessing the storage that you're providing, with whether that be over iSCSI, for example, or a file protocol. So in addition to whatever network utilization that the client normally would utilize, you'll need to add the network traffic for the for the storage as well, and
in the right direction, I might add, right?
Absolutely.
So if you've thought about sort of how does my EBS traffic influence my front side my front side traffic, they're going in opposite directions, and so a lot of times when people look at the storage bandwidths, they don't consider which direction is the traffic flowing in it. Some tools are good for this, some tools are not good for this. There's a lot of tools out there. We should talk about tools.
We should do a little talking about tools. And I think when we're talking about tools, it's important to understand it. As we were saying, sometimes there's a disconnect, whether you're looking at this from an application perspective or whether you're looking at this from an infrastructure perspective. And I think you would agree, Isaiah, that's important to see it from both those sides, so you can understand all the layers of it, and no matter if you're coming from the application team or from the IT side, there's different tools that you could run to get those performance and baseline metrics, across them. So whether you want to run something like Breeze, which we're going to demo in like a minute, which captures application side, information, or you are going to run something from system or storage, which a lot of storage vendors, as have like native capabilities to capture various I/O and throughput and latency and other information from there. But it's important to collect all that information and then being able to marry that information together to truly understand it and create an agreement between what the application teams believe is the storage profile and what you're seeing from the system side. And if there's any disconnect there, be able to understand where that is, whether that's some layer of caching that's happening, so that as you migrate that application, you're able to account for those things.
So the caching stuff is funny. I know that I've had clusters in the past where the core filers had almost no activity, but my caching layer was crazy busy, even just doing things like node-to-node fill. I know from the IT side of things, it's often the case that you can't modify your application, and if you look at most of the we'll call them like performance monitoring suites out there, they almost all require instrumentation inside of the application. And sometimes this is, you can still get statistics off of the host, but usually if you want to know what your application's doing, you have to provide some sort of instrumentation tool. So like New Relic or Dynatrace, AppDynamics, those kinds of things. There's other stats that they can gather, without instrumenting things. They can gather stats about what's going on in the system. I think New Relic's one's called StatsD. AppDynamics was one of the first ones to do even performance monitoring of stuff like Lambda functions. So you can gather certain information at the quote-unquote application level. But if you're talking about actual I/O, there's really only one way to do that, and that's to look inside of the system calls. So, which is what we'll be doing with Breeze.
So why don't we talk a little bit about this this tool set?
Yeah, sure.
So we can talk about both Breeze and Mistral, which are both by this partner, Alexis.
Alexis. So they're a small partner. They're UK based, and they really only do one thing, and they do it well, which is they help debug I/O problems by making tools that make it easier to do that. So we won't be demoing Mistral today, but we will demo Breeze. And so what makes it interesting is that the person who founded this company was a chip designer, and she was sort of sick of having performance problems in her own environment and figured that it was probably worth figuring out how to debug that stuff. And so she figured out an approach. That approach is, and they're really transparent about that, that approach is to overrun system calls by using LD preload entries. So their whole application revolves around the concept of using LD preload to intercept system calls and in a very, very lightweight fashion provide instrumentation around them. They don't just do file system I/O, they also do networking I/O. And the way that the applications tend to be used are that Mistral is the sort of thing that you would set up after you got everything sort of working the way you wanted to, and you'd establish that baseline once you'd moved, or establish that baseline inside of your environment once you've sort of figured out the problems. And then when you find a problem, Breeze is what you use to sort of dig into it. So it's a graphical application, it runs on Linux. I think if we, actually, can you go back to the previous slide for a sec? I think if we look at this list, most of the time when we talk with customers, and you guys could validate this for yourselves, most of the time when we talk with customers, they're talking from the perspective of being able to see what's going on in the application, or from the perspective of being able to see what's going on at a system level. It's very uncommon to have a chat with a customer and be talking with storage administrators. That just, I think, is a byproduct of the relationship that AWS has with customers. We tend to be more line of business focused, less sort of traditional IT focused. And that might shift over time. And the folks that I've noticed who have the relationship with the IT folks are our consulting partners and our ISVs. So if a customer comes through our field, almost always it's a line of business contact. And if a customer comes through one of our partners, almost always it's somebody in IT. So this is quite funny because usually they don't know that the other is talking with the customer. These groups don't talk with each other. And so the IT folks had no idea that their workloads were about to go to the cloud. All they maybe had seen over time was that their overall workload requirements had gone down, because they were running a multi-tenant pool of resources that they were sharing across multiple workloads. And then as those workloads either expanded out to the cloud or migrated to the cloud, all they could see was that there were less problems. So they didn't necessarily know what the cause of that was. Just everybody else was having a good day because the problem child went away. So these types of things, so, I'm sort of, is the title of the slide's a little bit cheeky, but you can't figure out the problem by looking at just one perspective is sort of the point. That it's very often the case that you have to look at multiple perspectives to figure out what's actually wrong. And so the easiest one that you have control over if you're running the application is to look at things like system calls. So, all right, cool. I guess it's demo time.
Yeah, let's go into this demo.
Okay, so this is a live demo. We had some challenges, so that's always good.
All right, we're praying to the demo gods. But just keep in mind, it is a live demo, so
all right.
Things could go right, things could go wrong.
So
I'll switch you over to.
Thank you. AV person.
2. All right, you should be on.
All right, cool. So this is what the yeah. Hold on just a second. Great. All right, I think I'm good. So this is what the application looks like. I'll just walk you through sort of the different areas first. So when you open it, and if you haven't done anything, and we're actually going to close it and we'll restart it when we run a program to generate a little bit of I/O, so you can see what it does. There's it's not the best user interface, as engineers typically don't create the best user interfaces. And it looks a little old-fashioned, but the data is there, and that's the important part. You can sort of see, I would say, the most important things, which are what are the rates and how long do they take? And there's a lot of different ways to dig into that data. So let's close this, and then let's run this application. Okay, great. So the way that you run it is there's a shell script, and you can see from the usage. Oh, BNC spaces. Oh, whoops, sorry, I did something wrong. If you don't mind, I will just check the README option. H. So you can take the results. They actually have a couple different licensing options. One of the licensing options that they have is that you can sort of just use the GUI to drill into things. Another option that they have is what they call trace only, where you can use their application to trace the information, but then not necessarily dig into it. Like if you were working with them in a consulting fashion, they might ask you to add this trace only option to various jobs that you're running, and then they would output the data, and then the data would be collected, and they would be able to help you interpret the results. So what we're going to do is we are going to run their trace option. And so the trace option, we're going to output a temporary file, and then we're going to load that temporary file into Tabriz. And you can give it any command that you like. It has a lot of other options, but for our purposes, all we're going to do is give it the temporary directory. So and then we'll give it a command. And we don't actually care about the output of the command, but what we're more interested in is the I/O characteristics. So if you're in a vertical workload like EDA, for example, something like 50% of most EDA jobs is metadata calls. And if you're in a workload like another HPC workload like oil and gas, you have sort of two types of general profiles. One is super small I/O, where you're seeking around in all kinds of random places in a file, and another one is all sorts of really, really big I/O. And in both of those cases, the way that these types of workloads progress is they do a bunch of stuff in parallel, and then they come back and they do a few things serially, and then they go do a bunch of stuff in parallel, and they come back and they do a few things serially. It's often the case that those few things serially are small I/O bound, or they're small I/Os, and they tend to be bound, CPU bound on the storage side, right? Sometimes it's actually disk bound, but usually it's CPU bound. Why is that? Because most metadata systems for storage systems don't scale, and this is true for everything from Lustre to Cumulo to Isilon to NetApp. When it comes to metadata torture, if you've ever run MD test, sort of the industry standard metadata torture tool, these tools will expose the scalability limits of metadata layers inside of solutions. There are a few that are pretty good. Like I personally recommend a product called Weka.io a lot. They have a very, very scalable system. I've run internally in AWS. I've run clusters in excess of 300 nodes. What that means for me when I run something like MD test is that I'm looking for how can I keep my application CPU bound, Because at the end of the day, if you want your application to run fast, you have to keep it CPU bound. So you want a platform that can feed it the data as quickly as possible. But if you're stuck on these single-threaded metadata calls, then it can't actually do the real data I/O part. So, all right. So then I run this, and then it asks for a saved trace. It's a Breeze trace. Oh yeah, you can also feed it strace output, which is pretty cool, actually. Go to the file system. We put it in temp, and it's B. So it's going to load that stuff in. And I know, because it was fined, that it's going to be mostly metadata on a local file system. This is a local file system, by the way, right? So we can attach EFS. I don't have FSX for Lester, which bums me out. But we can do some other stuff too. So this is actually a really typical sort of subsection of a workload that somebody has tried to move, and they have problems. And then when you go get the Breeze data, you find out, oh, it's actually because you have tons of small I/O. So when we look at what it considers to be bad I/O, it's things that are really small that actually should have taken a lot less time. So this is milliseconds duration. This is not microseconds duration. For a local file system, this is actually really slow. So why was it so slow? Well, it's on the root disk, which is EBS. EBS is not the world's most performant block device. It's a very scalable block device for a multi-tenant environment, but it's not the same thing as talking to a local NVMe device like an instance store. We have some of those too, so we can do some tests there. So we also see that we have a lot of 0-byte operations. Now there's a waterfall version here where you can explore if you have like a compile job or something like that. It will show you a tree of these things. It'll show you system environment variables. Now why is that interesting? Well, in organic environments, EDA is a great example again, where somebody's touched an environment for, like lots of different people have touched an environment over a period of 10, 15 years. Nobody remembers all of the scripts that people put in there, and nobody knows if all of that data is valid when they move a portion of their workload to AWS. So this is not just a problem for EDA, it's also a problem for media and entertainment. So I want to move a render job to AWS. What do I have to move?
Yeah, so there's a lot of components that really go into that,
So
right?
it's not just the binaries, right? There's a bunch of other stuff too?
Absolutely.
Okay. All right. So so answering the question of what do I have to move it can also be addressed with Breeze. And the reason is they can print out in Breeze a list of file system paths that you touched. You can extract the directories from that. So when you run your job and say, well, I know that this job is successful on-prem and I want to move it to the cloud, you can actually have a finite list so you don't end up with this massive sort of e-discovery problem of I guess I either have to move everything or I can't run my job. So that I have to move everything is great until you get into an environment that has hundreds and hundreds of terabytes and you have a 300 meg Comcast line. So that doesn't work well.
Or you end up in a dependency hell situation where you move something and then you end up,
Totally.
hey, my application is broke because it depended on 5 different things that I didn't end up moving because I didn't realize that the ad application actually utilized that. So I didn't scope it into my migration.
For sure. So let's see here. So here's our profiling data. So here's our I/O count. So we ran that find on /USR, and in the process of doing that, it generated 150,000 system calls. So if your NAS cluster is having a bad day, and you had something in a script that was doing something like that, and what it was trying to go do wasn't in memory, if it was potentially disk bound, the latency for all of everything that's on either side of the job is going to extend quite a bit. So what else can you discover from this? Well, I mentioned there was the whole path issue. And so since it went off and discovered a lot of directories, the directory list here is going to be quite long. But I don't think that that's unusual in production. I think it's really common for people over time to put things in lots of different places. And like I mentioned earlier, if you have something that was generated by people, they oftentimes don't even remember that they put it there. That's the whole reason they don't typically go back to things, right? If you have something that's generated by a computer, then it's possible that you would need access to all of that data all of the time anyway, and you probably can generate that list. The next thing that was interesting about these things is that there's inconsistency across even the same operations on the same media. So if you've ever used, if you've ever had a hot neighbor, sort of the noisy neighbor syndrome, in an on-premises environment, and you're running the same job now that you ran last Thursday, and last Thursday it was fast and now it's slow. Boy, that's the stub your toe bane of your existence, right? I don't know why this is slow. And meanwhile, the DBA is coming over telling you that I ran this thing last Wednesday and it was fast, and I'm running it today and it's slow. So these kinds of things where applications are stepping on each other, you can understand what the variance is, what's the high point of the noisy neighbor syndrome by looking at the amount of time that it takes for these system calls to complete. So for example, here's 2 opens. One's 2 microseconds, one's 5 microseconds. So it doesn't seem like it's a big difference in time, but in reality, it's more than 100% increase in time. So if you have something that's going over the network, and that isn't 5 microseconds, but it's instead 150 microseconds, and all of a sudden now it's taking 300, and all of a sudden it's taking 300 microseconds. If you have 150,000 of those, you're probably going to notice, right? So these kinds of things, they add up quite a bit. So the general point is that when you're looking at application data, it's important to be able to have real data that's generated as close to the application as possible. If you can only generate stuff on the storage side, then you only see half of the picture. And of course, you can get information about how things were invoked. So it does something quite nice for you, which is break down for you what the IO parameters are like. I'll just minimize this portion of the window, and I should be able to move this over here so you can see sort of what the top talkers are. And you can search through things as well. So it has a couple different views. So it's quite a handy application. So now to compare how long this thing took with another media, we'll just go back to our host where we have a couple other, let's see here, Shift Control T. Okay, great. So we have different types of EBS here and different types of instance store, and we have an instance store as well. So one of the things that people frequently I don't want to say don't take into consideration because it's definitely in the back of their mind, is that since AWS is a multi-tenant environment, and because different regions have different levels of popularity, there's this notion of sort of a wave of activity, which is to say that at night in one region, using one service, you might look at what you can collect from your application, and you might get one performance profile. In a different region on the same service at a different time, you might get a completely different performance profile. So this is sort of, it comes with sort of the good things. People come to AWS for the services, and then when you come here for the services don't give you a uniform experience. So this is one of those things that you sort of have to take the good with the bad. The teams that manage these services go to the ends of the earth to make the experience for each user fantastic. And one thing is for sure, when you provision, let's say, an EBS volume and you say, I want to get 3,000 IOPS, you will always get 3,000 IOPS. Not a penny more, not a penny less. So they've gotten very, very good at these kinds of things because they've been doing it a long time. There's a few other environments, notably a lot of on-prem environments, where you don't really have the capability of doing those kinds of things. And so the way that you handle noisy neighbor syndromes is by either buying more hardware or trying to segregate workloads, either by time or by where you're running them. So,
yeah, and I think it's important, since there are those different types of resources, as Isaiah is setting up the next demo, to actually test these workflows that you're running on AWS and the kind of agility you get by being able to just spin up EC2 instances, on demand when you need them, not having to necessarily, worry about having to pre-purchase or do anything like that. on them. So whether you're going to put your own application on there or whether you're going to spin up a solution for storage, you can actually spin up that real environment, even if it's for a day or for a few hours of testing, and you can actually try out your real workload without having to necessarily invest ahead of time in that before you really make that decision. So I think that's really important. So not only testing and baselining against your real workload, but actually testing your workload and against the various storage services. So whether that be testing it on GP2 volumes, which is just a general purpose volumes where you kind of get I/O capacity or I/Os based on the capacity of the volumes, or if you need to step up to I/O1 volumes, or even utilize instance storage, right? And the various different solutions, some of them support, using, your choice of essentially what type of EBS volumes or whether you use instance storage. So actually testing those options, helps, significantly.
Okay, cool. So we're going to now do the same thing that we did before, and we're going to do it partially just so you can see the difference between even with, forget about page cache, right? Page cache there's some amount of metadata that page cache helps with, but it doesn't help that much. So it's not, in other words, page cache is memory bandwidth type latencies, which means that if you have latencies that are network related, it's not going to help you everywhere. So we'll start with the instance store.
And just in case everyone isn't familiar with instance store, because a lot of people, especially who are just starting out with AWS, think of just EBS and everything is on EBS volumes. Instance store is available on certain instance types, and what it is local ephemeral storage. On the newer instance types, it's all NVMe based, so you get a very quick direct path to that local storage.
And then we'll generate the same sort of thing for EBS. And you might think, oh, this is just such a small thing, but I think you'll be surprised in the results that we see. So the instance store one came back immediately, even when we were executing additional stuff. This one is not coming back immediately. Great. And then just for kicks, we'll go kick it off for the other one as well. And we'll look at the instance store one for comparison.
Yeah, so this will give you kind of an idea of what the difference is, what it looks like when actually doing this against an EBS volume, over the network versus direct NVMe path to the instance storage that's local to that particular instance.
Cool. All right. So this is, and I'm not going to close the application. I'm just going to import another one. So we saw like 90 milliseconds total for the overall thing. This is the right run, yeah? Oh, I minimized the other thing. Where's it called? Here it is. Yeah. There we go. Back to normal. Okay, so 90 milliseconds of bad I/O, and if we look at the total time duration, 703 milliseconds overall for the first run, which was off of our boot volume. And then when we did this over in NVMe, the total duration was 1 millisecond. So you can imagine that if you were trying to profile an application on-prem and you got 1 millisecond and then you went to the cloud and you got 700 milliseconds, you'd probably be pretty upset because you have a 700% decrease in performance. So this happens all the time, and the knee-jerk reaction is, abort, go back to on-prem. But instead, you can figure out now why is this happening, and try other solutions.
And that's why this planning and testing that I mentioned is like so kind of important, because you don't want that to be happening at the time of migration, right? You don't want to go migrate your workload, then find out, customers complaining and you're getting 700 millisecond response time, and now you got to all of a sudden scramble and figure out, okay, well, am I going to fix this on the fly, or am I going to go fail back? And more often than not, the answer is going to be, okay, let's fail back and do this at another time, and then, customer has bad taste in their mouth, they don't want to move their application anymore. So you want to avoid that kind of situation. And you can easily do that using these kind of baselining tools. You run the the baseline on your on-premise environment, understand that IO profile, run the actual application or as close to the actual application as you can on AWS, run the baseline there, and try it with different options, right? Whether that be the native storage services, or whether that be a storage
Partner
system,
solution.
a partner solution that you can get from the marketplace, like WebIO or NetApp
Or Cumulo.
or
Yeah.
Cumulo or
And-
any of those.
We'll talk also a little bit sort of like how do I make a decision about which one of those is right for me, which isn't really in the scope of this, but people always ask that question, so we thought maybe it would be helpful. So I actually killed the fines on the EBS stuff because I thought that we don't have all day, and you guys probably have some questions to ask. But when you go look at this, yeah, I saw that. We'll go look at the PI ops one because that should be faster. So there's two ways for you to import the data. The first way to import the data is you can dig into all of the data, which we saw was a like 700 megabyte trace file. And then the second way to dig into it is just to load the profiling information. Profiling information is all that we need to see that EBS is slow. And so this is the kind of thing that you would probably do like a timer where you would say start, and then I'm going to run a program, and then I'm going to end, and I'm subtract the time. And you can do that from an aggregate perspective, but if you do that from a system call perspective, it gives you a much better sense of what's fast and what's slow. So, for example, you might find that the data path is very fast, but you might find that the metadata path is very slow, or inverse, right? It just depends on your environment. And I'm running this on a C5D 16, X16 or something like that.
I think it was
So
18x
it's
larger.
not too shabby, right? So this is a fast box. In the meanwhile, I guess I'll just pop the stack to that. What should I run discussion. So people often ask, I'm using X on-prem. Should I run the same thing in the cloud? Often the answer is, if you wanna. It depends on how you manage the data. So NetApp folks, and I was a NetApp customer for forever. If I had a volume that was on NetApp, it made sense to me to use SnapMirror to manage the replication and the migration of that workload. As soon as I get to higher level stuff, like let's say I'm using Oracle, it makes more sense to use DataGuard, right, or Golden Gate or something like that. If I'm talking about application data that's inside of a cluster, I'm probably not running NetApp anyway. I've probably got something that scales out more horizontally that I can still keep in sort of like one namespace, like an Isilon or a Lustre or something like that. When it comes to picking up and going into the cloud, a lot of people they look at the software, but they don't necessarily look at the hardware beneath it. So if you had Lustre installed on-prem and you looked at running FSX for Lustre in the cloud as like a scratch place to do work, the workflow that you have on-prem is to sort of set it up and leave it there. And the workflow that you have in the cloud would be to store stuff in S3 and then start your FSX for Lustre cluster, stage the data, load it into your Scratch environment, run your jobs, and then take your results and write them back out to S3. So what part of that do you care about? Do you care about how long it takes a job? No, you care about the total elapsed time. So if you have a ton of ingest data that you have to stage inside of that environment, maybe that's not the right solution for you, right? So in the media and entertainment space, where you have a mixture of clients, where you have both Linux and you have Windows, what you might want is things like multi-protocol volumes, and not just multi-protocol volumes, but fast multi-protocol volumes. And so in those types of situations, the first place that we often point people at is things like Cumulo and WebIO. If you are super comfortable with things like SnapMirror and you are using features like SnapVault or SnapLock, for implementing enterprise worm on your file systems, then things like NetApp Cloud Volumes on Tap make a lot of sense. And just to eliminate any ambiguity, NetApp has rebranded a bunch of stuff. The ONTAP software appliance is called Cloud Volumes on Tap. The one that they run out of a co-location facility is called Cloud Volume Services. So if you stop by their booth and they're telling you about Cloud Volume Services, that's run out of a colo. And it's a multi-tenant environment. You get a vFiler, and it's quite convenient. But when you start looking at your bill and you see all these egress charges, that's why it's happening. You'll know why after that. If you want control, then running something like ONTAP or Cumulo or WEC.io or Quobyte or BGFS or Lustre or any of these things make a lot of sense inside of your VPC. If you came to the cloud because you wanted services and you wanted less to manage, then looking at things like FSx Lustre make a lot more sense because, or EFS, right? Because in spite of the fact that you have the staging period that you're going to have to put up with, the trade-off is that you don't have any infrastructure to worry about. So only you can make the right decision for you, but those are the things that people often have to keep in mind.
Yeah, so those kind of methodologies and understandings is where we kind of steer customers to when we talk about the different filing solutions. But then it's important, just to reiterate the point once again, once you kind of narrow in on, let's say, hey, maybe I want to run, Cloud Volumes on Tap, maybe I want to run Cumulo because those kind of match the profiles of the features I need, those kind of match the scalability I want, you want to then go and actually deploy it, test it, POC it, see if it actually works the way you're expecting to. Because, again, AWS Cloud enables that to be a really easy and seamless process, right? A lot of those solutions that we mentioned, are available right on the AWS Marketplace. You could just go there, deploy them, test it, and understand really what that means before you have to go and make any kind of large-scale investment.
So I guess I wasn't being fair. I didn't capture the stat stuff. So to be fair to the EBS guys, because they work super hard, I'll just run it again without the stat. Okay, good. All right. There is data there. Okay, good. And it didn't exit cleanly, so we'll get a chance to see actually what Breeze says about stuff like that. Cool. So on EBS for IO1, the total elapsed time was 687 milliseconds. So that's a multi-tenant service, and although it was faster than my local system disk, which is also an EBS, it was faster because it was IO1, not necessarily GP2. It was still 687% slower than using Instant Store. So when people go from like on-prem and they've got their latest greatest DDN box, or they've got their latest greatest all-flash Isilon cluster, and they come into the cloud and they say, why is everything slow? This is the reason. The reason is they're used to local NVMe flash type latencies in a single tenant environment where they're not competing for anything, and then they're going to an environment that's not built for that. So, and that's where the FSx for Lustre comes in, and that's where third-party solutions like WEC.io come in. Okay, cool. So what did it say about how things died? We just go look at that. I feel like there's a button I can't see. Is there a button I can't see? Maybe there is.
Well, I think we can get the idea of the differences between, kind of the different EBS volumes as well
Sure.
as Instant Store from what we see in the I/O collection.
All right, cool. So we have 48 seconds left. So two things, I guess. One, thanks everybody for staying. We hope that this was able to extract value for you. And we'll hit the button. Is this the button? That's the button. Oh, that button. Is that the right button?
All right.
Right.
Yeah.
And then for some of the stuff that we talked about, we've got links up there if you want to dig into things. The most important part is when we go back to sort of those steps that, oh yeah, you guys can take pictures if you want. You can find all of these, by the way, on the marketplace or just by Googling. A lot of people, when they look at trying these things out, they look for, what's the cheapest for me to try out. So I guess I'll plug that in the partner organization, we actually have a credit fund. And so if you are interested in trying any of these commercial solutions out and you don't want to pay for it, then contact your AWS sales rep and say, hey, I want to try out this partner solution. What kind of credits can you hook me up with? And we have a process for doling out those credits. So you'd be able to sort of define what done looks like for your project. And what the success criteria are. That's part of the process for soliciting for funding of these kinds of things. And then we would be able to help fund this project. So if you've been looking at, I want to move a particular workload that might be quirky to AWS, and you don't have a budget to sort of play around, then this is a great way of taking care of that monetary problem. So thanks very much for your time. I hope you enjoy the rest of reInvent.
Thank you, everyone.